amounts of information beamed back to Earth by the tiny mechanical explorer. CNN's John Zarella has its story.
For 3 months last summer, 120 million miles from home, a robotic rover cruised around in an ancient riverbed on the surface of Mars.
I could have spent years directing that rover at that site. There were, 5 high priority things that I'd still, I would trade an awful lot to get,
There were dunes in the distance that needed a closer look, interesting rocks that beckoned, Martian storms to witness, and studies to be done on the curious magnetic dust covering the planet. Still, the science Pathfinder and the Shojourner rover returned was more than anyone dreamed. Pathfinder was billed as a technology demonstration. 90% of the mission's focus was to prove the ability to land on Mars with airbags, bounce across the surface, and deploy a rover. Getting science back was considered a bonus.
Nobody originally believed that a 2-foot-long rover could actually move around on Mars at all, much less accomplish science. And there it was, it did it.
We got 2.3 billion bits of information about Mars. We got 8.5 million individual measurements of the temperature and pressure. We got 16 chemical analyses of rocks and soil and surface materials. 16,500 pictures.
The pictures and data now have scientists rethinking many old notions of Mars. The most basic, its color. Pathfinder validated what the Viking landers had shown 20 years ago. Mars isn't a red planet.
It would be more believable to be rust, but butterscotch? A butterscotch Mars? I said, Justin Mackey is the guy, the scientist who's doing this. And I said, Justin, it can't be butterscotch. How can I go out and tell the world that Mars is the color of butterscotch?
Evidence from Pathfinder is enhancing the theory Mars was once Earth-like, a place where life might have gotten started.
That makes it a tremendously more compelling place to go study, I would say. It's not just, what kind of rock is that? It's, what happened? How did we get here? That's something even Joe Sixpack occasionally wonders about.
As Shojourner moved from rock to rock, unlocking Martian secrets, it also taught engineering lessons.
We learned what worked and didn't work about drive motors and things like that on Mars, which is a very different environment than the Earth.
In the future, we will do things differently. Our future rovers will have brushes to get the dust off the rocks.
Pathfinder lasted 84 days before the Martian winter zapped the last strength from its solar batteries. But that was long after Shojourner had left its cleat prints in history. John Zarella, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
Long a topic for movie screens or the fringes of society, the subject of unidentified flying objects may be about to become the center of serious scientific study. A panel of international experts says it's time to try to explain unexplained phenomena by looking at the physical evidence of reported UFO encounters. Joining us now to talk about UFOs and the panel's findings is Peter Sturrock of Stanford University. Dr. Sturrock, thanks so much for being with us.
You're welcome.
What is it about UFOs that suggests that really they ought to be taken seriously and looked into further?
I think we have the simple fact that for 50 years we've had many thousands of reports of observations, and these are not understood. The panel pointed out that any time there are unexplained observations, scientists may learn something by examining those observations. That basically is what we're suggesting.
Now, when you talk about observations, in fact, correct me if I'm wrong, I gather that the real interest is in looking at evidence. What is it about witnesses that makes them untrustworthy? What is it about evidence that excites scientific curiosity?
Well, you don't need either. You really need both. I think the panel pointed out that in order to do deep scientific investigations, you really need physical evidence, the kind of thing you can take into the laboratory. But in order to know whether it's worth taking into the laboratory, you must have strong witness testimony. And data collection and the evaluation of witnesses on the one hand, and examination of evidence, on the other hand, in the laboratory, they are two quite separate activities, best done by separate teams.
Are there specific episodes which have left behind physical evidence that you could tell us about?
There are a number. I believe that Mark Rodiger at QFOS drew up a catalogue of some hundreds of ground traces, but the panel was presented with just one case, which is rather interesting because it involved two different kinds of physical evidence. In 1981, a worker in his garden in France heard a low-pitched whistle. He saw a strange object approach from the air, hit the ground. After a few seconds it took off, and he noticed depressions in the ground. There's an official data collection organization in France called GEPAN, part of the French Space Agency. So they arranged with the gendarmerie, the national police, to come and check out the place the next day, talk to the witness. They then contacted the scientists in Toulouse, who went out and took ground traces and plant samples. They then arranged for the soil to be analyzed in one laboratory and for the plants to be analyzed in a separate laboratory.
That incident, the other incidents, all of the available evidence, do they make you and the other scientists that you've been working with believe that UFOs are out there and visiting Earth?
No, I think the panel made the statement that they did not see any evidence that convinced them either that UFO reports involve new physical processes or that they involve extraterrestrial visitation. On the other hand, they said we do not know what the causes are. There probably are several different causes, and the only way to get serious answers to that question is by doing serious research.
Peter Sturrock of Stanford University, thanks so much for this.
Okay.
And that concludes this edition of World News. I'm Prue Luan in London.
And I'm Jonathan Mann at the CNN Center in Atlanta. Stay with us. American Edition is next.
Trek to Saturn.
What goes up must come down, right? Well, maybe not. Much of what remains up there is piling up like rubbish. How worried are we about space junk anyway? And how worried should we be? Hello and welcome to CNN's interactive news program Q&A. And welcome to the Space Odysseys week here on CNN. I'll look at issues affecting and affected by space. Now, since 1957, nations with active space programs have launched tens of thousands of objects into space. Some has come down, but not all, and that's the problem. What remains is largely useless and orbits the Earth, potentially disrupting communications equipment and satellites, among many other things. Space junk. William Ayler is with the Aerospace Corporation Center for Orbital and Reentry Studies in California. Bill says that space is proving to be a pretty hostile environment with all the man-made debris. Clayton Morey is with the Satellite Industry Association, which represents U.S. commercial satellite interests, and he says that his group has tracked more than 9,000 objects bigger than a softball, including a pair of astronaut gloves floating in space. We'll ask Clayton how the debris is or might be affecting everyday use of mobile phones, beepers, and the like. But first, how man's love of space has turned the once untouched region into a vast wasteland.
1957. The world's first satellite is launched by the Soviet Union. Its name was Sputnik. For the first time in history, humans could hear and see an object of their own creation in space. And because the concept of machines orbiting the planet was so new, the eerie signal pulsating back to Earth was terrifying to many on the ground. Today, there are more than 2,000 satellites hurtling through space, and the technology that depends on them is so common that many don't give them a second thought. But only a small portion of those satellites, less than 200, actually work. The rest have become part of a junkyard in space. As they die, satellites gradually lose orbit and then burn up in the Earth's atmosphere. But sometimes they break apart first, colliding with other man-made objects or with debris from space. In all, tracking stations have picked up 23,000 objects the size of a grapefruit or bigger, zipping around at about 25,000 kilometers per hour. There have already been collisions, damaging U.S. space shuttles and taking out at least one satellite and a U.S. military rocket. The good news is collisions are rare. There's a lot of space out there. The bad news is that space is shrinking, with hundreds of new launches planned over the next 5 years. Companies like Iridium are putting up what they call constellations, groups of dozens of low Earth orbit satellites to be used in a wide range of new communications. Soon, cellular phone calls will be cheap and global, wireless data transmissions commonplace, and paging services greatly enhanced. But these advances come with a price. Just last month, a single satellite owned by Pan Am Sat malfunctioned on its own, knocking out now critical paging service to most of the United States. And it wasn't just pagers. Credit card transactions, national radio broadcasts, weather forecasts, all were disrupted by the outage.
Billion-mile trek to Saturn.
The more satellites that go up and the more that we depend on them, the more there's a chance that something like that, or worse, could happen again. And the newest satellites will be even more sensitive. Even the smallest space debris, down to the size of a coin, can easily destroy a satellite when they collide in space. And as scientists point out, there's just going to be a lot more stuff out there. A junkyard in space. A far cry from the lonely traveler in space 40 years ago.
Space junk. Do we have a responsibility to keep the skies from becoming too cluttered? Whose job is it to stop it? And what about cleanup? Contact us now if you have a comment or question for our guests. Remember, you can reach us via fax or email or phone the program at 1-404-525-6888, and our guests will also take questions from those in the Q&A real-time chat room that's going on right now. For now, we go to Los Angeles and Washington. Gentlemen, welcome. Bill Ayler in LA, let me start with you. Can you give us an idea of exactly what kind of junk is up there?
Well, junk ranges all the way from dead satellites. That's satellites that have reached the end of their mission and they die. In other words, you lose communication with them. They go from bits of debris that result from explosions of satellites on orbit. When the satellite explodes, it creates a lot of little pieces that stay in orbit. They don't just come down. It can be any number of things. The astronauts throw things out of the space shuttle. Those things become debris.
Clayton, let me get back to you then. Let's get over to you. Let me ask you, are we being careless about what we send up there? Are we being careless about how it stays up there? I mean, an astronaut's gloves should not be staying in space. I would think it's not an easy thing that you would lose.
Well, you would hope not. Certainly, in the past, practices about what we've put up and how that's impacted the space environment have been more lax. But the more that we put up, the more we're watching what we're going to orbit into outer space, and the satellite manufacturers and the service providers are becoming more aware of the environment which they operate, and they want to make that a clean environment. It's in no one's interest to litter in outer space and create harmful debris that could impact your satellite.
Well, Bill Ayler in LA, let me put this email question that we got across the internet to you. We had lots of response for this show. This question says, it's from Norway, it says, how long will it take before it's virtually impossible to deploy satellites and other spacecraft due to junk?
Well, we don't think that's going to happen. A number of nations now are getting together to work out a solution to this problem, try to prevent the creation of debris from the kinds of sources that have really created a lot of the debris we see now. So we're working to try to solve that problem so that it's not just a continuation of what we've been doing.
I'm going to ask Clayton to take the first caller on the line. Gert in Holland, your question, please.
Yes, my question is the following. All this costs a lot of money. A country like the United States, for instance, spends 7 times more on space programs than on the care and protection of the seas. Can you please explain what is the value for humanity? Thank you.
Well, I think there's a great value for humanity here. Satellite communications, as I think what we saw with the Galaxy 4 failure a few weeks ago, and the literally millions of consumers here on the ground that depend on satellites to provide communication services, things like paging, that doctors use to respond to urgent calls, telephone traffic, radio traffic, television programming, all is carried via satellite. We're expecting to launch some 1,200 commercial spacecraft over the next decade, valued at about $58 billion. And these spacecraft are literally global constellations of satellites that will be providing communications to men and women and children virtually every corner of the planet. And that is critical both to the economy and to promoting democracy around the world.
Bill, a fax question from Belgium came in, sort of related to sort of issue. It says, Is the price to clean up space junk in proportion to the decreased risk for a collision with working satellites? Is space junk as dangerous as it seems?
Space junk is, I think, a growing problem, and we've seen evidence of that. For example, we've had occasions where the space shuttle has moved in its orbit to avoid potential collision with space junk. And particularly with things like space station, which are very large, the probability of being something that large getting hit by something is a real issue. And that's one reason why we're trying to take cost-effective measures to reduce this problem. Spacecraft owners and operators can do a number of things, from venting fuel so they don't just have something up there that will explode, to removing their debris at the end of the mission, and that's the kind of thing we're beginning to see now.
We're going to pause for our first break here, back with more of your questions and comments about this intriguing subject, space junk, after these messages. Welcome back. Bill Ayler is with the Center for Orbital and Reentry Studies. He's joining us from Los Angeles in order to answer your questions about space junk. And in Washington, we're joined by Clayton Morey with the Satellite Industry Association. His group represents the U.S. commercial satellite industry. Our next caller's on the line from Israel. We've got Roy on the line. Go ahead, Roy, with your question, please.
Hi. Good evening. My name is Roy Avni, and I'm from Israel. Guys, a question. Everybody talking about taking the Mir space station down. Why not to keep it in a higher orbit for a future generation, for a museum piece?
Bill, you want to start with that?
Well, I think that might be a good idea. The issue with something that size is that it will drag in on its own. Just the atmospheric forces will cause it to come down, which means that you'd have to thrust it up to a higher orbit. And even deorbiting something this size is going to be an interesting trick. So, that's an interesting thought. It's a question of whether it's economically feasible to do that.
To Clayton Morey in Washington next with this question that's come by email from Pakistan. Clayton, it says, are there any organizations responsible for checking satellites to make sure they don't fail and become space junk?
Well, I think in terms of organizations, no. It's the companies themselves that make sure that their satellites are operating properly on orbit. They are licensed by different entities here in the U.S. The Federal Communications Commission licenses satellites. And internationally, it's actually the UN has a body that does some regulatory work on the actual orbital location. But in terms of policing that, it's the companies themselves that police their own efforts in space.
Well, Clayton, take this question as well. It's from our internet chat room that's going on. Our moderator, Matt Ivan, has a question here that says, it's clear that with the current pace of technology, the most advanced satellite today will be dreadfully obsolete within a short span. Do satellite designers plan for this contingency, and how do they generally deal with the problem of what to do with a dead or obsolete satellite?
Well, satellites' lifetime on orbit varies. In these new constellations of low Earth orbiting satellites, generally the lifetime is much less than those that we placed traditionally in the geostationary orbital positions. That is, the GeoArc is about 22,000 miles up. These ones in lower orbits are about 400 to 700 miles up. The ones in lower orbits, they tend to last about 5 to 7 years. The ones in geo orbits about 10 to 15 years. We plan in for the satellites, both for the debris issue, the space junk issue, to make sure that they can take the impact of meteorites and other particles that might hit those spacecraft. We try to put all the critical technologies pointing towards the Earth so they're not exposed to that environment. And then we try to do some things on the design side that allow for flexibility in the spacecraft so they don't become obsolete because they are up there for several years.
Okay, Paul in Austria, thanks for being on Q&A. Go ahead with your question, please.
Hi, my name is Paul, calling from Austria. Nice to talk to you tonight. My question would be, you talked about development or about reducing the creation of space junk, but you never talked about technologies collecting space junk again. So maybe there would be like a flying sponge or something that would collect that chunk again and reduce it that way.
Bill Ayler, is that a possibility?
We've heard people suggest things like a big catcher's mitt that you would use to catch debris. The trouble is that the debris is not all in one place, so it would take a very maneuverable object to be able to go after it. The kinds of things that people have considered would be a ground-based laser that would perhaps move the debris enough to make it re-enter the atmosphere. That may be a more likely type of activity, but that's a long way off.
Well, Bill, let me ask you, what exactly is a piece of junk that's considered a threat? How big does it have to be a threat?
Well, anything, as the opening thing said, about the size of a quarter or larger is a threat. So, you know, these things move at very high speeds. That's what causes the problem. And anything, you know, that size or larger is really a problem.
There's an email question here that says, are there any satellites in space which are harmful to the health of humans? Bill, I think this is actually your domain as well, isn't it?
Yes, there are some satellites that are up there. There are old reactors, reactor satellites that would be harmful to humans. But those are put in orbits where they will not come down for a long, long time until the radioactive elements have decayed. So they should not, in the long term, be a hazard.
All right, Bill, Clayton, don't go away. We're going to take another short break here on Q&A. Space junk is our subject. We're back in just a moment. Let's return to our guests. We've got Bill Ayler in Los Angeles, Clayton Morey in Washington. Clayton, I'm going to get to you with a question about the kind of things we might see in the future as the risk with debris may increase. We saw with the PanAmSat Galaxy 4 satellite failure just recently the risks that we face, communications being knocked out, radio stations going off air in places and so on. How much are we starting to depend on all that now?
Well, actually, historically, if you look at satellite communications, our failure rate is less than 1%. In fact, satellites are often thought of as the most reliable form of communication, more so than terrestrial networks here on the ground, because there's all sorts of weather and hurricanes and backhoes that can cut your line or your fiber optic cable. So satellites, while we have a lot more going up into space over the next coming 5 to 10 years, we think that we've got a fair degree of redundancy built into those systems and a high degree of reliability based on the technology we've been able to deploy over the past 40 years.
Now, an email question came in from Germany. I'm going to put this to Bill Ayler. It says, does space junk burn up the minute it enters Earth's atmosphere? And could the moon serve as a disposal site for space junk? I think we're going to get sued by the man in the moon here, Bill.
That's right. Space junk, unfortunately, not all of it does burn up. There have been cases where we've had large items re-enter and survive. We had a 500-pound stainless steel tank land next to a farmer's house in Texas a year or two ago. That made his morning, needless to say. And so not all survive. So even though you bring things down, you want to do it carefully. Relative to using the moon as a disposal site, the issue there is going to be the amount of energy it would take to get something to the moon. So that's probably not a very viable approach for many missions. In some cases it might be, but I would say in most cases it's better to have them re-enter the atmosphere in a safe place or put them in what's called a disposal orbit.
Clayton in Washington, there's a question here on our internet chat room. This would be in your domain here. It says, even if the space garbage could be collected, what would be, in your opinion, the best method of disposing of it? Some satellites, for example, are powered by nuclear energy.
Well, I think the best disposal is to actually deorbit something and have it burn up on reentry. I'm not aware of any other collection mechanism where you can capture something like this and bring it back down, except for in a very unique case, the shuttle went up and actually captured a spacecraft and brought it down in its bay, although that's a very costly proposition. So I'm not aware of any techniques right now that we could use, and so I guess it's tough to comment on it.
Bill, there's a question here on our message board. People actually can leave questions in advance or 24 hours a day on this, and it says, by the way, who's owning the material that's floating around, given that there are satellites launched by different nations and so on? Who should pay for the cleanup?
Well, basically what we're trying to do now is to make it so that the satellite owners, when they dispose of something at the end of the mission, rather than to just leave it there so that it will become a hazard to other spacecraft, that at the end of the mission they deorbit it or put it into a safe place, and I think that's a better way to deal with that issue.
Now, Clayton, when organizations, space agencies and so on, NASA's and so on, plan their launches, how much do they have to take into account the risk of what they might hit up there?
Well, they do, but space, as you said in the opening, is a very big place. These satellites are literally thousands of miles apart from one another, so it's not as crowded as one might think. But certainly they're aware. They have orbital windows. They track this stuff out at the Air Force out in Colorado, tracks the debris that's up there, and they're pretty careful about where they launch.
But now, does the technology, Clayton, allow for the equipment? You were talking about it being developed to take a certain amount of impact, but when you have, as Bill was saying earlier, the risk of even a small, something the size of a coin causing damage because of the speed and so on, Clayton, does the technology really allow for protecting the pieces up there?
Well, it does. There also is a degree of, as I say, redundancy built in on these new constellations of satellites in the lower Earth orbits. They're building in spares on orbit just in case a particle does come in and have some kind of impact. In the rare instance, they'll be able to move another spacecraft in to fill that constellation and then deorbit the satellite that does not work properly.
Mm-hmm. Now, Bill Ayler, what do we know exactly about what's happening up there? I mean, natural collisions and so on and so forth. What serious impacts in space near the Earth have been recorded so far? Do you know?
Well, we've had a number of events where we've actually had a lot of debris created by explosions on orbit, and we've had one satellite that was hit by a large piece of debris, seriously damaged. They subsequently were able to recover some of that mission because of some of the redundancy that was mentioned earlier, but that's been the only major spacecraft damage that's been recorded to date.
We've got Mats on the line from Denmark. Go ahead, Mats, with your question.
Thank you. I have a simple question. You have a lot of satellites in orbit, well around 200, 300 that are still alive, sort of. Isn't it possible to use the space shuttles to refuel them? I mean, the lifespan of a satellite is usually dependent on the fuel aboard the satellite.
Actually, I should give that to Clayton in Washington. Has that been considered by the agencies?
Well, it's very expensive, as I say, to fly the shuttle. A shuttle mission costs several $100 million to put up there. You're putting human life at risk. In doing this, it tends to be something that's not a very cost-effective way to do it. Now, the satellites that orbit in the traditional geostationary belt, that is 22,000 miles up, the shuttle doesn't fly nearly that high. It's only a few hundred miles up, so it's out of the question that they'd be able to go up and swap that out. It's not like the Hubble Space Telescope, where they can come up and just do a refueling mission.
Now, Bill, in actual fact, you have to assess the risks to a certain degree for the agencies. That's part of your job, I guess. Yeah. To what extent is there a need to insure, I mean, quite heavily against what might happen to the hardware that's being sent up there?
Well, I think that it was made earlier. The point was made earlier that the risk right now are, I think, very small. So there are a lot of other ways a satellite can fail than getting hit by a piece of debris. So we think the risks are pretty small right now. The concern that we have is that given the number of new launches that are going up, the new satellites that are being launched, what's it going to be 10 years from now? And so that's why there's a lot of effort going on now to really limit the amount of new debris that's created.
Clayton, a last comment from you as we're running out of time now. Confident that the technology is allowing us to minimize that debris the way Bill is saying?
Yeah, I think so. We've got a lot of very bright engineers working on mitigation techniques here, either positioning the spacecraft in such a way that they don't get hit by these pieces of space junk, or building in harder protection on the outside of the spacecraft so these things don't knock it out of control. So I think we're in good shape right now.
All right, Clayton Morey in Washington and Bill Ayler in Los Angeles. Thank you both for being on Q&A, taking the questions from around the world.
Thank you, Riz.
Now, be sure to stay with CNN for Space Odysseys, our week-long look at issues in space. And don't forget that Q&A airs live 5 hours earlier than usual on Thursday. It's the day that the U.S. President Bill Clinton arrives in Hong Kong. We'll look at the state of democracy in the Chinese territory. That's Q&A on Thursday at 14:30 hours GMT. We'll see you on the next Q&A, but for now we say goodbye. Stay tuned. The news continues here on CNN.